Lesson 9. Archimedes is one of the most well-known mathematicians in all of history. When asked by the king of Syracuse to determine if a crown was pure gold, Archimedes took the challenge. He discovered his answer while taking a bath. He realized that when he got into the tub, a certain amount of water was displaced. He could do that same with the crown. Excited, he screamed, "Eureka!" and took off to tell the king. We will control the level of water in the bathtub by turning on and off the tap, taking the plug in or out, and by having Archimedes get in and out of the tub. This will create a graph relating time and depth. So as we do this, we're going to describe the changes in the graph. So the first thing we're going to do is we're going to turn on the water. So 1, turn on the water. So as we turn on the water starts to rise. Number 2, put plug in. So when we put the plug in, it starts to raise even faster. So this is 1, and this is 2. So 3, we're going to turn the water off. When we turn the water off, it goes straight. We have a horizontal line. So now 4, Archimedes, gets in the tub. Well, that tub rises. That water rises. Next, he stays in the tub. Well, when he stays in the tub, it's level. 6, he gets out. So that comes back down. 7, the water sits in the tub. And 8, we take the plug out. So now it says, what would be the fastest way to overflow the tub? Well, with Archimedes in the tub, plug the tub, and put the faucet on full power. B says, describe the conditions under which there should be no change to the level of water in the bathtub. The plug is in. And the water is off. Okay. So next, we have the graph below. Oh, let me fix that. There we go. The graph below represents the total number of smartphones that are shipped to a rental store over the course of 50 days. Okay. So now it says, read through the scenarios and sketch a graph of the function that models the situation. Well, the production schedule was normal and the smartphones were shipped to the retail stores at a constant rate. Well, when that happens, it's simply continuing at a normal pace. Okay. So then it says, a defective electronic chip was found and the factory had to shut down. So no smartphones were shipped. Well, at that point, nothing was shipped, so we have a horizontal line. Okay, so this is 1. This is 2. Then 3, it says half of the factory workers went on strike and not enough smartphones were produced for normal shipments. So at that point, we still have production, but not at that same pace. So it would be at half. So this would be number 3. So number 3 says, the graph below shows the distance from Lewis's home as he walks his dog in his neighborhood. Describe the change in the distance from his home over time. Well, first, Lewis is walking away from his home. Next, and here's where he's walking away from his home. That's number 1. Number 2, he stops. And you can pretty much say anything here. He stops to give his dog a treat. In class, we used Cece's example, and she said, stop to have the dog take a potty break. And you can say anything. He stopped and played in a park. Anything that you want. Next, for number 3, he continued down the road. And number 4, he turns around, turns to go back home. Okay. So next, our next 2 scenarios that we have here says not all real-world situations can be modeled by a linear function. There are times when a nonlinear function is needed to describe the relationship between 2 types of quantities. Compare the 2 scenarios. Alf is running a constant rate on a flat paved road. The graph below represents the total distance he covers with respect to time. Shannon is running on a rocky trail that is initially flat and then leads up a steep mountain. The graph below represents the total distance she covers with respect to time. So now it says, in your own words, describe what is happening as Alf is running during the following intervals of time. So here we have, for the first 0 to 15 minutes, he runs 2 miles. From 15 to 30 minutes, he runs another 2 miles. Total, 4 miles. 30 to 45 minutes, another 2 miles. Total, 6 miles. And 45 to 60 minutes, another 2 miles. Total, 8 miles. Oh, sorry, spelled that wrong. And this is a constant rate. For Shannon, over the 15 minutes, runs about 1.5 miles. In 15 to 30 minutes, about 0.6 miles. Total, 2.1 miles. 30 to 50 minutes, or 30 to 45 minutes, about half a mile. Total, 2.6 miles. 45 to 60 minutes, about 0.4 miles. Total, 3 miles. Here it's increasing, but at a decreasing rate. Okay. So next, basically what this is telling us is the rate of change of a function can provide useful information about the relationship between two quantities. A linear function has a constant rate of change. Nonlinear function has a variable rate of change. And our charts are just comparing those two. So you could look at those charts. Next. So for practice, Nika took her laptop to school and drained the battery while typing a research paper. When she returned home, Nika connected her laptop to a power source and the battery recharged at a constant rate. Sketch a graph that represents the battery charge with respect to time. Well, if you notice that a battery normally will charge at a constant rate, so I am going to just simply do this. And the reason that I'm doing that is that normally when a battery charges, will charge at a constant rate. It's not very fast where it will go up here. It's not very slow that it will go down here, but it normally will go at a normal constant rate, which is why I drew that line. So does the function represented by the graph linear or nonlinear? Linear, because the battery is charging at a rate. At a constant rate. Okay. So does the function represented by the graph increasing or decreasing? Increasing. The battery is being recharged. Okay. Next. It says Lamar and his sister are riding a Ferris wheel at a state fair. Using their watches, they find that it takes 8 seconds for the Ferris wheel to make a complete revolution. The graph below represents Lamar and his sister's distance above the ground with respect to time. Is the function represented by the graph linear or nonlinear? It is nonlinear. Where is the function increasing? Increasing at 0 to 4, 8 to 12, 16 to 20, 24 to 48, 28, and 32 to 36 seconds. It says, what does this mean within the context of the problem? Lamar and his sister are rising in the air. Because where is the function decreasing? Decreasing at 4 to 8, 12 to 16, 20 to 24, 28 to 32, and 36 to 40 seconds. Lamar and his sister are traveling back towards the ground. How high above the ground is the platform for passengers to get onto the Ferris wheel? The lowest point which is 5 feet, and that is where the platform is. Where the people get on. Okay. Based on the graph, how many revolutions does a Ferris wheel complete during the 40-second time interval? 5 revolutions. The lowest point is the beginning. Of a new revolution. What is the diameter of the Ferris wheel? 40 feet. The lowest point is the base of the Ferris wheel. And the highest point is the top. So the difference is the diameter. And that is the end of our lesson. Oops, sorry, I didn't let you see that. Sorry, guys. There you go.